Now I would like to talk about the combination of the two motion, which is translatory and rotatory motion. Before moving ahead to discuss the rotatory and combination of translatory and rotatory motion, I would like to discuss about the rotatory motion in a rigid body. So for a while, consider the two bodies I'm going to make here, something like this. This is the first body, something like this. This is the first body, something like this, and this is the second body, something like this. Right, for example, this is a pivot point, a fixed joint point. So something like this has been drawn from here. This is a, for example, consider a point A. This is the point A. This is the point A. This is the point. This is the point A dash. From here to here, this is a theta. C to B dash. Here and C to C dash from here. And this side, this is the angle theta. So as you can see here, the displacement of A to A dash may be equal, but A to A dash and B to B dash is not cannot be equal in any case, right? However, the theta A is equal to theta B and B dash. That can be equal, but the displacement is not equal because they are rotating through a pivot point and coming to different displacement. If we talk about the next factor here, now I'm going to discuss here, which is combination of translatory and rotatory motion. The combination of translatory and rotatory motion. The combination of translatory and rotatory motion. Okay, let's discuss it. Combination of translatory and rotatory motion. Let's take example of with the help of three circles. So 1, 2, and last but not the least, the third. So let's take an example. First, I'm going to write here is translatory motion. In translatory motion, we only talk about the forward velocity, right? We only talk about the velocities applied and moving in a forward direction. This is such a messy, looking very messy. So let's erase it. Let's take a sharp nib so that I can explain it. So let's take it. For example, this is basically a velocity. Velocity direction is always forward. It is always in a forward direction. The velocity direction is always forward. The velocity direction is always in a forward direction. Something like this, which is always acting in a forward direction. So this is basically a pivot point of axis of rotation. If we talk about the circular, this is basically a translatory motion, rotatory motion. So this is basically a rotatory motion, and this is the tangential velocity acting at every point, which is velocity is equals to omega r. Velocity is equals to omega r. All point it is same, something like this. Tangential velocity acting at any point, and our body is rotating in a circular path, and our body is rotating something like this. Body is rotating in a counterclockwise direction, or this, which is a combination of translatory and rotatory motion. And you can see here this velocity applying, along with that it is rotation, something shown like this, and it has tangential velocity as well, something like this. So it's basically a combination of translatory and rotatory motion. We know that this is basically a combination of translatory and rotatory motion. Let's take an example with the help of this diagram so that it will be easier to understand for you. As you can see this boy here, for example, let me erase it and I'm going to show you this boy. What does the picture is trying to say. So let's take this boy here. Let's just increase the size. Let's just increase its size. You can see here that you can observe the four translatory and rotatory motions. First is rotatory, rotating about its point, which is something like this. Tangential velocity is also acting at every point. Tangential velocity is also acting upon every point, something like this. Tangential velocity is also acting upon every point, and the motion is in forward direction, which is translatory. So it's a combination of translatory and rotatory motion. Both motions are combined here, which is translatory and rotatory, and you can observe this translatory and rotatory motion in a single body. But we talk about the two. Do we need a pivot point to explain it?